In this space mapping tutorial, we're going to use a simple XY space to illustrate how the neurons can learn examples and model a decision space based on these examples. So the input is going to be just the XY position of the cursor, and whenever I click inside the graph, I'm going to teach that input as with the category selected to the right. So if I click in the decision space, which was originally empty, what's happening is that that position XY, which is 86 and 116, is stored as category 1, which appears in red. One neuron has been committed, and all the area around it shows its influence field. This influence field has been set to the maximum authorized value of 128. Now, we're going to teach a different example belonging to a category 2, and I'm going to select it at this location, 166, 107. If I click, I can see that 2 neurons have been committed, and the influence field of the first neuron has been shrunk in order to fit the second example. So they're both excluding one another, which means that if I move the cursor in the green area, the point is recognized as category 2, which you can see in this scroll box here, category 2, and I'm at this distance 50 of that second green neurons. Now, if I move on the other side, the cursor, tip of the cursor is recognized as belonging to the neuron with category 1, and I'm at the distance 60 of that neurons. If I move the cursor in between, we can see that we have an uncertainty, and the tip of the cursor is recognized as category 1 with a distance of 51, but also category 2 with a distance of 52. And you can see as I move the cursor that I go back and forth. Now, if I'm outside, it means that I'm in an area of unknown and nothing is recognized. So we can add more examples, and for example, one of category 3. If I click here, then we'll have a zone. We're creating a decision space with a zone of category 3, category 1, excuse me, then category 2, and we even have a zone of uncertainty with 3 possible categories. If I teach a fourth example, which belonging to category 1, but I select a location that already falls into the influence field of the first red neurons, we can see that nothing happened. We still have 3 neurons, no new neurons has been committed, and I can do so. Now, on the other hand, if I teach this category 1 as falling in the influence field of the neuron, the blue neuron, it's going to shrink. Same for the green. And as the more example I teach, the more refined the decision space I'm building. So RBF is ideal for building a non-linear decision space. In the choices of the space modeling, we have the option to use 2 different norms in the CogniMem chip, the L1 and the L sub norm. And what it defines is the shape of the influence field of the neurons. So if I were to use L sub distance, the influence field would cover a square area, where the default L1 distance is more a diamond-shaped area. Now, keep in mind that in this demonstration, we limit the decision space to 2 dimensions, X and Y. In the CogniMem chip, the neurons can hold a pattern of 256 components, which means that they can model a decision space of 256 dimensions. If you're interested in practicing with this demo, it can be downloaded from the CogniMem website, and you can look into more detail at the impact of the minimum and maximum influence field during the training. You can also review the content of the neurons and switch between KNN and RBF to understand how the neuron responds to these 2 different classifiers.